Hi all, welcome to Nuage Academy. Before we start learning about Amazon Virtual Private Cloud, we should have the ground level knowledge about the IP addressing and subnetting. This is a prerequisite, will keep you comfortable in learning the Amazon Virtual Private Cloud. So first, we will learn how the IP is structured. Okay, if you take this IP 96.22.147.45, which is having a 4 octets, okay, which is structured in a octet notation. There is 4 octets out there. Okay, so the total 32 bits are divided into 4 octets. That every octet will have 8 bits. Okay, so 8 bits into 4 octets equal to totally 32 bits involved in a IP address. So this IP is represented in a binary format as below. This 96 has been represented in binary as 011000000 and 22 like that. Okay, this is each represent a octet. Okay, there are 4 octets as we said earlier. So if you see this binary to decimal bit value table, every bit is having a value. Okay, for example, if you take that is 2 to the power of 0 is 1. Okay, and 2 to the power of 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 16, 2 to the power of 5 32, 2 to the power of 6 64, and 2 to the power of 7 128. So every bit is having a value. If it is on, then that value has to be taken into account. So in this example for 96, it is represented as 011. So let me represent that in a binary format in this table. That is 0 1 1 and then rest all 0. Okay, so if you see the on bit, that is which is on, which is having a value 32 and 64. So if you add both this 62 and 64 and 32, which is 96, is the IP. The same way for 22, which is represented by the 5th bit, 3rd bit and 2nd bit. So let me take this, that is 2nd bit is on, okay, and then 3rd bit is on and 0, and this is on. Rest are zeros. If you add this is 16, and then this is 420 and then 22. So that's how it is represented. That is this binary representation 96, and this one is 22, and this is 147, and this is 45. So this is how the IPv4, that is 32-bit address is represented. So in this slide, we are going to see about the IP address classifications. IP addresses are divided into totally 5 classes. Okay, there are 3, that is class A, class B, class C, class D, and class E. And class ABC is used in your local area network and in wide area network. Okay, it may be in your inside your organization, or it may be wherever in the local area network you can use this IP address in this classes A, B, C. Okay, and class D is reserved for multicasting. So we are not going to discuss about what is multicasting. So if you want to know about what is multicasting, I'll just give you a high level view, where for example some subscription you are making for a particular TV and all that. And so based on the subscription, it will be distributed. The traffic will be distributed. Okay, so that is multicasting. Okay, that is for a group of people. It will be sent. So that is about multicasting. So I don't want to go into that much inside here. So we are in a totally different learning in this case. And class E, it is reserved for research and development. So nothing we have to worry about these 2 classes. So let us learn more about this class A, class B and class C. So here class A starts from 0 and ends at 127. So this is if you take the previous IP which started with the 96, right, and then I think 22 something. So this first octet can either it can be 0 or up to 127. It can either it can be 0 the first octet, or it can be 1 2, like that. It can be up to 127. So whatever the IP address starts from this range from 0 to 127, it falls under the class A. Okay, and class B, the IP starts from the range 128 to 191. So the same way. So if the any IP starts in 128 or 129 up to 191, this IP ranges falls in class B category. Same with the class C. So whatever the IP starts from 192, 193, 194, so up to 223, it falls under class C network. Okay. So this you have to remember. So by seeing your IP, the starting IP, that is the first octet. So you have to understand what is it comes from which class. Okay, it is going to help you to decide further things in your learnings. You are going to learn those things. So that is the reason I am telling you that you just make a note of it. Class A starts from where and ends with the what range. This is the range of IP starts. So the IP, let us take IP like 96.22.145.47, whatever. So this IP is having network bits and host bits. Okay, so you know now that this IP 96 comes from class A, right? So this IP is comprised of network bits and host bits. So class A will have one network bit, that is the first octet is a network bit, and then rest of the 3 octets are host bits. Okay, so that is the reason we are having class A. We can get around 16 million IPs from this class A, because these are all host addresses. So what is a host? Host is a specific device in the network. So every device will need an IP. So maybe it may be a printer, it may be a laptop, it may be a server, whatever. So what is a network? Network is a group of devices. So if you take this is one network, you will have someone server, your printer, whatever, your laptop. Okay, so many things. All these things come down. It forms a network, and so host is a specific device in the network. So class A is having the first octet as a network bit, and class B having the first 2 octets as a network bit, and class C has the first 3 octets as a network bits. So all these classes is having a subnet mask. Okay, using this subnet mask only, the network bit will be here also is the same structure, that is 4 octets. So here the network portion will be covered with 255 as a number. So what is this 255? So you know that if you see in a binary representation, so 1 1 1 1 4 5 6 7 8 dot, all rest will be 0. 3 4 5 6 7 8 dot, 2 3 4 5 6 7 8 dot, 1 2 3 4 5 6 7 8. So so this is the representation of 255.0.0.0. Okay, so here class B, it is having you will have all these bits will be on position, so it becomes 255. So if you add all these values, you know that we have a table in the previous slide we discussed about. This is having a value of 1, this is value 2, this is 4, this is 8, this is 16, this is 32, this is 64 and 128. If you add all these things, you are going to derive with end up with 255. So so the on bits, the 2 octets will be on with the 255. So that is the reason it is having 255. The same way The class C is having 3 network bits, so which contains all these 3 octets is on. Okay, so here class A we can yield around 16 million IPs, and in class B around 60,500 and odd 535 billion. Those IPs can be derived from, you can get from class B, and in class C it is, there is only one host bit, so where we can get only 256. So in other words, if you want to know how many networks or how many hosts in a network, so if you take a class C, it is just nothing but how many bits in this host bit. It is 8 bits, right? So that is 2 to the power of 8 is the 256. So here 16 bits are there, so 2 to the power of 16 will be the, that is 65,536 or 35 something. So here it comes 2 to the power of 24. So those number of hosts you will be getting, that is 16 million. So the same way in the network, if you see here, you will get the network 2 to the power of 8 networks you will get. Here you will get 2 to the power of 16 networks. That is some simple mathematical calculation you have to do. So this is the how your IP so now the structure of an IP, where it is segregated with 4 octets, and the class A ranges, for class B range and class C range, and all your IPs will have a network portion and a host portion, host bit we can say. Okay, let us move on to the next slide to get more understanding on this. Next we are going to learn about the IP categories. There are 2 types of IPs are there. One is private IP and another is public IP. So before getting into that, let us examine a situation. Suppose in your organization, or you want to access google.com, which is, you have to go through internet, okay, and you have to Google site is there, google.com. So what you have to do, your IP has to travel all the way to internet, and then it has to reach the Google, and then Google will respond back and you will come back here. Okay, so if assume that you are having one particular IP, maybe 192.1, whatever IP you take it, 1.1 something. Okay, you are into one organization and there is another organization. Okay, so they are also using the internet and they are also using the same IP range. Okay, so what will happen? So your request goes, so let me take one more organization. They are also using the, assume that it is just an example, assume that they are also using the same 192.168.1 dot something. So because this 3 makes a network, so 3 octet makes a network, identify the network. So these 3 guys are using the same range. So when you go for Google, when it respond back, it will get confused where to go to send the response, whether to here or whether to here or whether to this organization. So there will be a confusion. So to sort this out, what they did, IANA is the organization who takes care of about all the IP related things. They are the authority for the IPs. Okay, so what they did, they made a private IP and a public IP segregated. Okay, so with private IP, you cannot use those private IP to travel in the internet. That will not, they restricted that you cannot use a private IP to travel in the network. So this private IP is for your internal usage only. If you are inside your organization network, and if your systems want to communicate within that organization, it is well and good, you can use your private IPs there. Okay, so where the different organization also can have the same IP range, so it will not, because it is internal only, so it is not going to get clashed in the internet. So, and it is not routable, this private IP is not routable to the internet. Okay, so other IPs apart from the private IP, we have to buy the public IP to use for internet purpose. So these are the points you have to know that are used with LAN or within the organization, not recognized in internet. It will be issued by your administrator, network administrator, So this IP will be unique. Whatever the range you are using, that one system and another system will not use the same IP. So it will be unique within that organization, not with the other organization. And it is free of cost also. Private IP, there is no cost involved for private IP. Yes, but there is a cost for public IP. And it is also called as unregistered IP. Public IP, the characteristics, it is used on public network, that is in internet. It has to be issued by the service provider. So they will be having a link with IANA. So they are the authority for the IPs. And those IPs will be globally unique. Whatever IP is issued to you or to your organization, that will not be issued to anyone else. And they will maintain those database. And there is cost involved, as we said earlier, and it is also called as registered IP. So in our next slide we will see what is the range of private IP. So the private IP ranges, which is reserved in class A, it is starts, the network starts in the first octet 10. So the whole 10 network has been blocked for private IP ranges, 10 network. Okay, and the same way class B has been blocked. It starts from 172.16, 172.16. So whatever. So if you complete this 255.2, then you can move on to 172.17 network, and then 18 network, and then 19, up to like that. You can move on to 172.31 and then it goes. So this is the range it is blocked for class B, and here class C is blocked for this range 192.168.0 to up to 255. So in every network you will get 256 IPs. If it is zero network, then you will get 256 IP. If it is 1, then it is going to, you will get another 256 IPs in this range. If it is 2, again 256, like that you can go up to 255. So that is the private IP range reserved. Now, so far some basic understanding of IP we got. Now we will move on to subnetting. So what is subnetting? Subnetting is the process of dividing a single network into multiple smaller networks. So for example, if you take a class C IP, that is 192.168. It can start from 0. So let me take it as 1.0 network. So here, this is, very well, the 3 octets are related with the network bits, and this is the host bit. So how many hosts I will get from here? It is 2 to the power of 8, which is 256. Okay, and remember some basic things. So it starts from 0, that is 1.0, and then it 1, 2, 3, like that. It will go up to 255. So it is 256. So it starts from 0, so it ends at 255. Okay, so this many IPs I will get from this network. And remember, this 0 is a identification of your network. Okay, so network ID they will say. So you cannot use this as a IP. You cannot use this one. And also the last one, you cannot use it. This is for broadcast purpose. So if you get 256 IP in this network, you have to minus 2 IPs. That is equal to 254 usable IPs you will get from the class C network. Okay, so that you have to keep it in mind. Always you have to minus 2 whatever the network it is, because the start number, that is 0, it denotes a network ID, so we cannot use that as a IP for a host. And the last IP is for broadcasting purpose. We cannot use it for unicast purpose. Okay, so these are all IPs for unicast purpose. Okay, so we have to minus 2 those, minus 2 from this 256. So usable IPs are 254 IPs. Remember that. So keeping that in mind, we'll go forward. So subnetting is a process of dividing a single network into multiple smaller networks. So it minimizing the wastage of IP address. Okay, so you may say that okay, I will come with an example. If you see this diagram, in engineering department, I need 40 hosts to be hosted in that network, and then HR needs 20 hosts, and sales need 20 hosts, and some support team needs 20 hosts, and executive manager needs 15 hosts. So First of all, why we have to subnet it is that, for example, if I have a network, okay, this which I have systems connected here, okay, if this is in network 192.168.1.0 network, so the IPs will be 1.1, 1.2 like that. So if all the servers belongs to the same network, then it can communicate with each other. So the communication will happen if it is in the same network. If it is, so some systems, okay, let me, some systems, okay, in 1.0 network and some systems are in 2.0 network. So assume that this portion is in 2.0 and this is in 1.0, that is network ID. So what will happen, only these systems in this network can communicate, this to this or this to this, like that. Sorry, here it cannot make a communication between this. By default, this communication is blocked because it is two different networks. Okay, so you will get a isolation by default. If you want to happen, the communication happen, that is a different story. So that we have to configure. Okay, by default, I want to isolate my different networks. So then it is a good choice is to go for subnetting, and also it minimizes the wastage of IP address. For example, okay, so now we know that class C you can get 256 IP. So here I have 192.168.0.0, this network I am using for this. So this is, you know that this is the, sorry, this is the network bits and this is the host bits where I can get 256 IPs. But I need only 40 IPs, but here this network is going to yield me 256 network. Here there is a different subnet I want, because I don't want this communication to happen default. Okay, so 20. So the what I can do, because if I put in the 20 in the same network, it is going to get communicated. So I don't want that to happen. So I have to put it in a different network, 192.168. This time maybe 1.0 network. So that will be assigned here. Again, my requirement is only 20 hosts, but I have 256 minus 20. I am going to waste so much IPs. That is, it is going to be 236 IPs. I mean minus 2, then it will be 234 IPs. I am going to waste here. So in such a way, it is going to happen for every department. If I want to maintain that default, communication should not happen. So then I have to put it in a separate network. Okay, and if it is going to be the requirement is going to be less count, then I am going to waste so many IPs. Okay, this is private IP, that is fine, no cost involved. But assume that if a organization need 10 IPs, okay, then how they are going to give those IPs? So in public IPs, no, we cannot use those IPs, waste those IPs. So that is the reason subnetting is coming, but it is followed in the local area network also. Okay. So keeping that in mind, let us move further. You know that subnetting is the process of dividing a single network into multiple smaller networks. Subnetting helps in minimizing the wastage of IP address. So in subnetting, there are two types of subnetting. Is there one is FLSM, that is a fixed length. For example, if I have a class C network, so where this range is 0 to 255, so 256 IPs are there, where I can fixed length, I can make it as 4 networks, where this will get some 64 IPs, this network will get 64 IPs, this network will get 64 IPs, and this will get 64 IPs. This is called fixed length, FLSM, fixed length subnetting. Okay, so this is one way of subnetting, and another is VLSM, variable length subnetting. So in variable length, maybe maybe higher here. So this might be having 64, and this might be having 128, and further it is chopped into something. Okay, so this is, you can take it as like a school where the classrooms are equally all the classrooms will be in there. same shape or in the same forfeit area. This, such kind of thing you can compare it with this. Here if you see no, you will have like a house, individual house, where you will have a hall, a bedroom, restroom, washroom, whatever, a sit out area. So like that will be having a different lengths. So that is the thing. We are not going into particularly with the FLSM or VLSM concept, but just I am going to go in for subnetting to make you understand for our AWS learning the VPC, Visual Private Cloud. So let us have before actually we're jumping into before doing subnetting, let us have some understanding here. So subnetting can be done in two ways, which I was discussing in the earlier slide. It is FLSM and VLSM method, and subnetting can be done based on requirement. So I want to make no engineering department, I need 40 IPs, and my sales department requires maybe some 20 IPs. HR, I want some something, I can say 60 IPs. So whatever, for examples I'm making it. Okay. Subnetting can be done based on requirement. Requirement of host, there is a formula. So if the requirement of host is 40 IPs, okay, that is 40 IPs you want, then the formula is 2 to the power of h minus 2. So h denotes host bits. Okay, if you want to calculate the networks and how many requirement you want, then it is going to be 2 to the power of n greater than or equivalent to requirement. Here 2 to the power of h minus 2 greater than or equal to requirement. Okay, so let me so what is subnetting? Let me tell you one thing. So you know that if you take a class C, so I'm going to try to explain you this point. If you take a class C that starts from 192.168.0 whatever 0, so this 3 octets makes what it makes? It makes the correct network bits. So how many bits are here? So every octet has 8 bits. So 8 plus 8 plus 8, it is 24 bits, right? And what is this is the host bit. So here how many bits are there? Here 8 bits, correct, right? So what I am doing in subnetting, so if I use 8 bits as a host bit, so how many IPs I am going to get? 2 to the power of 8, which is 256 IPs, that is minus 4, minus 2. So 254 IPs I want to get. But here my requirement is only 4, right? So I don't want this many 2 to the power of 8. So what I am going to do is I am going to reduce the number of host bits. So what can I do? I can move, maybe here I can make the network bits as 25 and the host bits as 7. So then in that case it's going to be 2 to the power of 7 IPs I'm going to get. Okay, if otherwise I can further move down if I want. So I can make it as 26 network bits and I can make 6 host bits. So that is the point here, converting host bits into networking bits, reducing the number of host bits, in other words. So that makes the subnetting, okay, according to your requirement. So let us take an example and let us do the subnetting. We will go back to the same example where my engineering team needs 40 IPs or 40 hosts has to be going to be get hosted there or connected to that local area network. So I need 40 IPs. So how can I achieve this? So if you see here, 2 to the power of 5 is only I will get, if your host bit is 2 to 5 bits, then I am going to get only 32 IPs, but I need 40. So what is the formula? 2 to the power of h minus 2 greater than or equivalent to requirement. Requirement is 40. Okay, this is the formula. So here 32 to the power of 5 is 32. 32 minus 2 is 30, which is not greater than or equivalent to 40. So it is not going to help me. So let me take the 2 to the power of 6. So in this situation I am going to get 64 IPs. So in this case 2 to the power of 6 is 64 minus 2 greater than or equivalent to. So this is going to be 62 and greater than or equivalent to 40, which is true, right? So that is the closest I can take. Okay, so in this situation this is the fine. So maybe my IP range is class C network 192.168.1. Okay, so this is my network bits, you know. So as you know, this is 24 and my host bits 8, but I need only 6, right? 2 to the power of 6. So what the 2 bits will be added here, 26, and then it is host bits going to be 6, right? So now how to make that no the systems understand this is using this 20, because uh, we know the subnet mask for class C is 255.255.255.0. This is our subnet mask for class C, but so which is nothing but the host bits identification. So 20 here, what happens here, all bits are on in this 25, 1 2 3 4 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. Okay, so here, so how many bits happen here? Totally now 24, but we need 26. So what will happen here, it will add 2 more bits here for the it will take that for the network bits. So what will happen, the subnet mask here, that is in this portion, 2 bits is on for the subnet mask. So the subnet mask, so if that is the case, 2 bits is on, so what is the value for that 2 bits? It is going to be 192. So because you know very well that 2 to the power of 0 is 1, 2 to the power of 2 to the power of 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, and then 16, and then 32, and then 64, and then 128. So these 2 bits are on now for network. So if you add this, this is going to be 192. So the subnet mask going to become 255.255.255.192. That's how you will borrow 2 bits to the network. So you will be using only 40. Okay, so keep this in mind. Let us go further. Now how many networks we got from this one larger network? Okay, so we know that subnetting is dividing a large network into multiple small networks, right? So let us see that. I know that I will get 64 IPs. So my IP range starts from 192.168.1.0. I cannot use it, so let me make it as 0. Okay, and then it ends at, let me put it in another way. Let me put it in another way. That is my IP, my network. I'm going to, because we know that one single network we are subnetting into multiple small subnets. So one single network, which network we have taken 192.168.1.0 we have taken under this 256 IPs. So we subnetted and we reduced it into multiple small subnets. So here in this case, what is going to happen? Let me take it as 192.168.1, and what is the first IP and what is the last IP? I have to find it out. Okay, so here you know that it is 64 IPs. So it is going to be start in 0, right? And so 0 to 63 is the 64 IPs, right? Then this subnet will start from 64, this network. Okay, so 64 plus another 64 if you add, that is, it is going to be 128 is going to be start for the next network, right? I think I'm right. Let us see that. So now the first network starts at 0, second network starts at 192.168.1.64 because this is up to 63. So the last IP is 63, and 192.168. This one is 128. That is the next network. So it is going to be 127 is the last IP for this, and the other network is 192.168.1.1 ends at 255 because it starts at 0, right? Sorry for that small calculation missing. So this is going to be 192. So every network will have 64 IPs. So 64 minus 2, it is valuable IPs are 62. So 0 is the network ID and 63 is the broadcast ID. You cannot use these two IPs. Rest you can use it. Here this is the network ID and this is the broadcast ID. You cannot use it. And again this is the network ID. You cannot use it, and this is the broadcast ID. You cannot use it. For this network, this is the network ID and this is the broadcast ID. You cannot use it. Okay, so this is how you have to make your subnetting. So hope you got some idea on this. The knowledge I would like to give to you for that VPC understanding, so you will get a better VPC understanding from this knowledge. So if you have any doubts on this, feel free to discuss with me. I am happy to explain to you. Thank you.